Hyolim from KAIST KORAIL Railway Standard Mobility Program. Today I will present the findings of my study, Service Quality and User Satisfaction in Korean High-Speed Rail Stations, analyzed using structural equation modeling. Here is an overview. In the introduction, I will describe why I choose to study user satisfaction at high-speed rail stations. In the literature review, 6 service quality factors will be derived and the corresponding hypothesis will be developed. Chapter 3 presents the research design and data collection process for the online survey, while Chapter 4 explains the 2 analytical methods. The result will be presented in Chapter 5, followed by the discussion and conclusion in the final chapter. Let me begin with the introduction. Why do we need to study user satisfaction at high-speed rail stations? According to the UN, the global urbanization rate is over 80%. In Korea, it exceeds 90%. Urbanization increases demand for public transportation. In Korea, KTX and SRT carried more than 120 million passengers in 2025, and demand for high-speed rail continues to grow steadily. Previous studies suggest that improving station-level service can be more cost-effective than improving train operations. However, most studies have focused on overall rail service, accessibility, or commuter rail systems. Therefore, this study fills that gap by focusing on user satisfaction at high-speed rail stations. This study has 3 objectives. First, the study measures user satisfaction at high-speed rail stations using 6 service quality factors derived from the SERVQUAL framework and prior studies. Rather than directly applying SERVQUAL, this study developed 6 factors tailored to the characteristics of Korean high-speed rail stations. Second, this study applies CB-SEM for causal modeling of the relationships among the service quality and user satisfaction and reuse intention. Third, this study examines how different user characteristics affect evaluation of each service quality factors through multiple regression analysis. Next, I will explain the theoretical background and hypothesis development. I selected SERVQUAL as the theoretical foundation because it is one of the most widely validated frameworks for measuring service quality across various service industries, including transportation. And its dimensions are flexible enough to be adapted to different contexts. From SERVQUAL, I derived information, safety, and step service. To better reflect the physical characteristics of the rail stations, the tangibility dimension was expanded into comfort, convenience, and facilities. In addition, Servicescape theory further supports this distinction. According to this theory, the 6 quality factors can be classified into 2 domains, the physical environment domain and the human functional service domain. Based on the SERVQUAL framework, the green boxes represented the 6 service quality factors, while the yellow boxes represent the 2 outcome variables based on prior service research. So all 8 variables are latent variables, meaning that they cannot be directly measured. Therefore, each latent variable was measured using multiple observed variables, identified through a review of approximately 100 previous studies. For example, comfort is measured through indicators such as thermal, air quality, and lighting. The study uses 2 analytical models. First, Model A applies multiple regression analysis to examine how user characteristics influence each service quality factor individually. Multiple regression was selected because it allows directly interpretation of user group effects. Second, Model B uses CB-SEM to examine the causal relationship among the service quality, satisfaction, and reuse intention. CB-SEM was chosen because this study aims to test the theory-based causal structure rather than explore new relationships. Based on these two analyses, this study develops hypotheses related to service quality and user satisfaction, and then examines them. I will now explain the process of developing the hypothesis. First, Model A examines 6 hypotheses on how user characteristics influence each service quality factor using multiple regression analysis. For example, hypothesis 1.1 predict that frequent users will evaluate comfort lower. Next, Model B uses CB-SEM to examine how the 6 service quality factors influence satisfaction and reuse intention. Specifically, each service quality factor is expected to positively affect satisfaction, and satisfaction is expected to increase reuse intention. To examine all 13 hypotheses proposed in Model A and B, data collection is required. So I will now explain the survey design and data collection process. The questionnaire consists of 59 items, including screening and consent questions, service quality items, outcome variables, and demographic characteristics. Data was collected in February 2026 through an online survey conducted by DataSpring using the online platform Panel Now. The target population was adults who had used KTX or SRT within the previous year. From an initial pool of 3,000 responses, 60 responses were excluded due to invalid or low-quality responses. This resulted in a final sample of 1,020 respondents after quality screening. The sample showed a relatively balanced age and gender distribution across most age groups. However, respondents aged 65 and older were underrepresented in the sample, likely because they are generally less familiar with online surveys. The right side of the slide summarizes key user characteristics such as usage frequency, dwell time, and travel purpose. These variables were later used in the analysis to examine the proposed hypothesis. From this point, I will explain the specific analytical method. As introduced in Chapter 2, the analysis consists of 2 stages. In Model A, factor score extracted from the CFA are used as dependent variable in 6 separate multiple regression models. In Model B, the measurement model is first validated through CFA, and then the structural relationships are estimated using CB-SEM. All analyses were conducted using Amos 27. In equation form, the analytical models can be summarized as follows. In Model A, service quality evaluations are explained by user characteristics through multiple regression equations. In Model B, the measurement model examines how well the observed survey items represent each returned construct, while the structural model estimates the causal relationship among the returned variables. Based on these 2 analytical models, I will now present the result of the survey data analysis. In particular, the analysis focuses on 2 key questions. First, which service quality factors influence satisfaction? Second, how user characteristics affect service quality evaluation. First, these are the results of the multiple regression analysis. The table presents standardized beta coefficient. Positive values shown in green indicate more favorable evaluation, while negative value shown in red indicate less favorable evaluation. Only statistical significant results are shown, and non-significant results are marked as NS. Elderly users gave more positive evaluation of comfort, information, and safety than younger users. In contrast, users with mobility constraints gave significantly lower evaluations of safety, convenience, and facilities. Short-stay users who spent less than 10 minutes at the station also gave lower evaluations of staff service, convenience, and facilities. In summary, the hypothesis that elderly users evaluate information more positively was supported, while the hypothesis regarding dwell time and facilities was partially supported. These findings highlight the importance of user-centered service strategies for elderly and mobility-constrained users. Next, these are the CFA results for the measurement model. Overall, the model fit indices were within acceptable ranges. Most return variables also showed acceptable reliability and convergent validity. This suggests that survey items were internally consistent and appropriately measured each return factor. In addition, discriminant validity was also examined to determine whether the return variables were significantly distinct. The green value indicates that discriminant validity is satisfied, while the red value indicates that the criterion is not satisfied. This result is mainly because physical environment factors such as facility and convenience showed high correlations with each other. Some Hyolim cases were also observed in the fully specified CFA model. However, the SEM structure model remained stable after estimation. Despite the partial discriminant validity issues, the structure model was stable. Among the 6 service quality factors, facility and information showed statistically significant positive relationship with satisfaction, while step service showed a marginally positive effect. Satisfaction also showed a strong positive relationship with reuse intention, and comfort, safety, convenience were not statistically significant. However, it does not mean that these factors are unimportant. Rather, the results are likely influenced by the high correlations among the service quality factors. Therefore, the hypothesis related to information, facility, and reuse intention were supported, while the hypothesis related to step service was marginally supported. The remaining hypotheses were rejected. These findings suggest that improving facility, information, and step service may help enhance user satisfaction and reuse intention. Finally, I will present the discussion, conclusion, and policy implications. Based on these findings, several important implications emerge. As shown in the Chapter 5, facilities and information service were significantly positive relationship with satisfaction. And satisfaction showed a strong positive relationship with reuse intention, indicating a strong loyalty pathway among high-speed rail users. These results also revealed segmented perceptions across different user groups. From a policy perspective, prioritizing facility quality, improving real-time information systems, and universal design may help enhance user satisfaction and encourage reuse intention. But one limitation is the high correlations among the physical environment factors. Due to this multicollinearity issue, the independent effect of comfort, safety, and convenience on satisfaction could not be clearly distinguished. Another limitation is that satisfaction and reuse intention were measured using only 2 items each, which may limit reliability. In addition, elderly respondents were underrepresented due to their relatively small sample size. Further studies should incorporate additional measurement items and objective environmental data. This final slide summarizes the key findings of this study. This study addressed the research gap in station-level service quality for Korean high-speed rail stations. Based on the SERVQUAL framework, 6 service quality factors were derived and validated to examine user satisfaction at rail stations. Facilities and information showed significant positive relationship with satisfaction, while satisfaction strongly predict reuse intention. which may further lead to increased user loyalty. The results also revealed distinct service perceptions among elderly and mobility-constrained users, emphasizing the importance of user-centered service strategies. Thank you for listening.